Hey there, everyone. My name is Ryan Schul. Welcome to my channel. So, in the topic today, I want to talk about isolation forest and show how this can be a very effective tool for finding credit card charges that look a little bit sus, right? If your credit card charge is a little bit suspicious, this is a great way to tease it out. And you can't just say it's a bunch of low credit card transactions. You can't just say it's a very high credit card transaction. And that's something that's excessive or something that's unusual. You really have to look at the overall patterns and the anomalous patterns compared to the regular patterns, right? So it's not just high, it's not just low, it's not just infrequent or highly frequent. It's how these transactions occur relative to the whole group. Okay, so it's very interesting. Let's jump in. I'm going to show you how this stuff works in just a second here. So this is really basically called unsupervised learning. With supervised learning, you have certain outcome that you would expect, and that's what you're trying to measure, and that's what you're trying to predict. In this kind of scenario, it's much more like clustering because this is unsupervised learning. That's what it's represented as. Okay, so in a corporate spend data set, you rarely see fraud or illegitimate transactions, right? But that's what we're looking for, right? So we have to compare the overall group and then the outliers to the group. And that's what isolation forest is going to do for us. So it can handle high dimensional feature sets, expenses that aren't just high amounts or high frequency, right? It has to be something that's kind of unusual compared to the rest of the group. So we can look at rolling 730-day averages, different countries, different regions, different regimes where transactions occur, right? But again, it's not just those types of things. It's like everything, everywhere, all at once, all mixed together. And we have to figure out like what doesn't really belong or what doesn't match the patterns of the whole group, okay? So this is very robust, looking at skewed distributions. Isolation forest, abbreviated IF, is excellent for that. It's great for finding expense data that is somewhat skewed, either slightly skewed or heavily skewed. It works well with data that focuses on how to isolate these specific transactions from the rest of the group. Okay, so I think I beat that horse to death. Let's jump into it here. So I'm going to scroll down, and you saw my notes over there, so you can read that at in your leisure time. So let me go ahead and run this. Control Enter to run. I am going to create some transactions. Now I don't have actual credit card transactions, right? If you did, you could load that from a CSV into this tool, right? I'm trying to make this robust and scalable, both up and out. I don't have credit card transactions, right? I don't work for a credit card company or a bank or anything like that. I'm just showing you a very realistic example based on transactional data that I'm basically making up. Okay, so this is sort of what's it called? Sort of fabricated, right? If I had real transactions, I could look at it. I don't have these, right? So I am creating this to be realistic, but yeah, you're not going to find credit card transactions online. Hopefully, I mean, maybe you could, but that would be very, very weird, right? So let's just make up a real example of what we would probably see if we're actually doing this for a bank or for a financial institution, and you can go ahead and load your own credit card data. So let's say we have IDs of people that work for their company. We have a timestamp, the amount in US dollars, the merchant where the transaction occurred, MCC, country, credit card, present, and then the channel over here, okay? So we have the synthetic data. I call it synthetic data. We can go ahead and create some features. So I have the basic data set right here. So this is data frame text, just short for TX, right? So I'm going to go ahead and append a date and a weekday, an hour, and is this a weekend or is this not a weekend? I think these kind of data points could be helpful for the analysis, right? And maybe there's some type of pattern. Maybe on certain dates, there's more excessive credit card charges, maybe Friday night, maybe Saturday night. So maybe the hour is important, maybe the weekday is important, and is or not weekend, that could be important. And again, I don't know, just out of the gate here, I'm just trying a couple different ideas, and I'm trying to figure out like what can help me determine something that's anomalous and doesn't fit the pattern of the overall group. Okay, so this is called feature engineering. If all you have is some basic features over here, we can go ahead and create some brand new features from this timestamp right here, right? So that's what we're trying to do. So now we have the original timestamp, we have the IDs, merchant, country, card, channel, things like that. Then we have the date is weekday. What hour of the day is weekend? Yes or no. So 0 is no, 1 is yes. Okay, so this is a weekend. And the channel, and then 7-day rolling mean. So I'm creating a couple new features. Again, I want to understand the whole group. I want to understand the averages, the means, the standard deviation for 7-day rolling averages, and then rolling 30-day averages, right? So if you have some kind of infrequent, weird kind of transaction, maybe, if somebody's doing something suspicious, maybe they are just making these transactions at a specific time of the day, a specific day of the week, things like that. Maybe there's a rolling average that can help us tease out these kind of anomalous types of events, right? And again, it's not like excessive use or high frequency use of the credit card. We just want to see what is the overall group doing and what's different from the group, right? So that's what IF is going to do for us. So we have these extra features that we just created over here. So I think this is going to be helpful in the overall analysis, okay? So Control Enter to run this cell. And by the way, I'm kind of skipping through the code a little bit fast here, but I'm going to give you guys all the code, okay? So if I sat here and like explained every single line, what is this doing? What is this? And what is this loop for, and the purpose of all this? First of all, this is my own insight and my own take on this. So I'm not saying this is the gospel truth. You have to do it this way. This is one solution. There's probably dozens of different ways to solve this problem. Okay, so I don't have time to get into all the details and all of the logic behind it, but I will share all the code with you, like I do for all of these notebooks, all these Jupyter notebooks I put up there. When I post a video, I'll post all the code so you can copy and paste it and run this in your own environment. And then obviously, if you have questions, Google it, go to ChatGPT. If you have very specialized, very specific questions, you can post that in the comment section and I'll try to address that. But like when I share the code with you guys, I encourage you to roll up your sleeves, right, and do a little bit of work and get into this, make a few changes here and there, see what the impact is, see what the ultimate outcome is. That's how you're going to learn from these examples, right? Like if you just run the code, like just hit Control Enter and run the cell, you're probably not going to learn a whole ton, right? But if you get in there and kind of massage the code a little bit and make some changes and see what kind of impact you have, right, and see how the outcome is ultimately affected, you're going to learn a ton from that, right? So I'll give you all the code. I don't have time to get into all the nuances and all the details of the code in the video here. Otherwise, it would drag on for hours and hours. So at this point, we're ready to start testing isolation forest. So we have the original data frame. We created some new features from the original features, right? So we have the means, the standard deviations, the 7-day rolling average, the 30-day rolling average, and so on and so forth. So now at this point, we can start to look for anomalies in this data set, detect those anomalies, right? And report on those. And then ultimately, we will contact the people that come up in this report, the anomalies, and reach out to them, set up a quick meeting. Okay, we saw your name pop up on this credit card report and we're doing an isolation forest exercise. This transaction looks a little bit suspicious. Can you justify this, right? Like what's going on? So you set up a few meetings with these people. Obviously, you're not going to audit the entire corporation, but anything that comes into this isolation forest report, that is definitely a good beginning point for a conversation with the person, okay? And there could be a totally valid reason why this credit card transaction occurred, but if it looks very suspicious and it shows up in the IF report, then you might want to have a meeting with this person, right? So higher isolation reports anomalous or unusual occurrences, transactions relative to this. I'm calling this a scientist, right? Data scientist, research scientist or whatever. Let's say that this group of people, it's going to be anything. It's going to be engineers. It's going to be somebody that has corporate credit cards, right? Maybe a consultant if you work for a big four or something. I'm just calling this a scientist. It's just a random name. So we're looking for anomalous and unusual activities from the scientist's history relative to the peers, right? The peer group. But this thing shows out. It shows up different. It's kind of like bubbling up a little bit different, right? So these are the transactions that we have to focus on. So the reason could be human readable explanation of why the model flagged this transaction. That's what isolation forest is good at, taking all this stuff, right, and putting it into a big blender and looking for transactions that just kind of different from the rest of the peer group, right? It's kind of unusual, kind of just weird, like why is this showing up, right? So it's all relative to the entire group. So if we go over here, so at this point we have days since the last transaction. Is this rare or not compared to the group? And then the merchant rareness in the past 180 days, yes or no. So these are just little flags that we're setting and we're creating to help us with the IF analysis. So now we have the data. We can start to do the actual analysis here. So we have transaction features, amounts, robust, z-score. So z-scores are differences from the mean. You'll have like the z minus the mean divided by the standard deviation. If you don't understand it, go ahead and Google it, look that up. So rarity of transaction, rare for the merchant in the last 180 days. Again, the means, the standard deviation, 7-day and 30-day transaction counts. Okay, so go ahead and run it. I think I just did run this one. Let me just do it again to make sure. Okay, so at this point, we are going to go ahead and put everything into an X variable. So you have all of the data right here, okay? So I explained this in a lot of my other machine learning videos. You have everything right there. You are creating a copy of this. I like to create copies just because you don't taint the original data or mess it up. And because if this, for some reason, got messed up or the calculation was wrong or whatever, I'd have to go back to the original data and like rerun the whole process. So I think it's best practice personally to create a copy of that. So if something doesn't work out in this copy of the data frame, I only have to go back to the cell. I don't have to go all the way back to the beginning. So I just like to take copies of this thing. So I have the data over here. I'm taking a copy of it over here. I am looking for the overall median number just to fill in any missing values. I don't think there's missing values here because I created a synthetic data set from the beginning. If you have real data, you could have missing values, right? So I think mine is pretty clean. I think it's just good practice just to fill in any missing values. And we're going to go ahead and take all of this, scale it. So whenever you're working with some type of clustering data or what is it called? Mine's trying to blank. Non-supervised learning. That's what we're doing. Whenever you're doing non-supervised learning, you really want to scale and fit the data because you could have extreme data points in some places and then non-extreme in other places. You want to take that and kind of create a similarity or sameness of all the data. Otherwise, the outliers can really affect the overall group. And we are looking for outliers. That's what we're looking for. But we still want to make everything relatively comparable to the group and then look for outliers. Otherwise, like I kind of alluded to before, you can have a large transaction. It can be anything, 10,000, 15, 20,000 charge on a credit card. And you can say, ha, that looks very suspicious. That's definitely an outlier. But maybe that's the normal transaction, right? Like maybe a partner at a law firm or a consulting firm is flying first class. They're going halfway around the world. And that's a big plane ticket, right? But that's not suspicious activity. He's just getting to the site for the consulting engagement or for the law practice, something like that, right? So you can't just look at these big transactions and say that's an outlier, right? You have to compare that to the rest of the group. So that's why this type of analysis it's a little bit, it's very interesting. It's a little bit hard to describe, but it's not just like filtering out the top 1 or 2% or the bottom 1 or 2 or 3% or whatever. It's much more complicated than that, right? So anyways, we take all the data, scale it, put this to an X variable, fit that into the model. So we're using isolation forest. I have a couple hyperparameters that I'm tuning right here. So number of estimators, contamination, random state, number of jobs. Just Google it. This is pretty standard practice. There's a few other parameters that we can put in there. I think just for our case today, I think this is very realistic. I think this makes sense. So we have the isolation forest here. The model is trained, tested, looking for the same X variable, right? So you can call this whatever you want. The standard practice is to call this X. And we're going to take all of this, run the isolation forest process on this data, and then assign that as a new column inside of this data frame, right? So here's a new column. It's called isolation forest score. That comes from this variable right here. And this is the isolation forest model, which comes from here, okay? So hopefully just look at the flow of the pattern. Everything flows together and it looks pretty nice. So we get down here, we get the final isolation forest score. Here's the score over here. Forest predictor, is this anomalous or not? Anomaly flag percent, and then final anomaly, right? So what you really need is this score right here. These are nice to have too. It's just adding a little bit more feature richness to this analysis, right? But what we're really looking for, what we're really looking for is right here, the isolation force score. That's the most important. These are just some other nice to have flags. Don't necessarily need it, but I think that does add some value to the analysis. And again, we're focusing on the score here. And I'm looking at the head and the tail of the data. So everything looks pretty good. I'm going to go ahead and plot the results. So I always say this, all my videos, a picture is worth 1,000 words. We have the isolation forest score right here. So that is the key to this whole thing. That's probably the most important element. It's all based on all of these other fundamental features over here that we picked, right? And don't forget, it comes originally from this right here. So we have the basic data frame. We create some new features. It's called feature engineering. From those feature engineering new columns that we created and appended into the data frame, we're using that to train the isolation forest model, and it's going to give us a score. So hopefully that makes sense. So down here, we can go ahead and plot the results. Okay, so this one kind of stands out. This is, okay, so this is for a hotel. The amount is $3,406 for the charge of the hotel. So that one definitely jumps out. But again, we're not looking for these big transactions. I can just put this to Microsoft Excel and just say, okay, just like show me the top 10, right? That doesn't mean that this is anomalous. It doesn't mean that this is some kind of suspicious charge on the credit card. We're looking at this charge, is $3,406 charge relative to the group. So it is not the mean by any case of the imagination. It's definitely like a higher charge, right? There's a couple others that are higher, but are these the anomalies or not, right? That's what we have to determine. So when we get to this plot, we can see how everything shakes out relative to everything else. Most of these charges are pretty low. They kind of like congregate down here in this view right here. So most of them I would say is under $500. But again, we're looking for these anomalies. So if you look here, anything that is kind of in the median kind of expense charge right here lines up with the 0, right? We're looking for the z-score or the deviation from the rest of the charges. Anything that has an anomaly flag is going to be in yellow, okay? So we're really focused on these yellow expenses over here. I don't care about the blue. And you can see some of these yellow charges also fall on the 0 line. But again, you have to trust what this isolation forest algorithm is doing. It's calling these out as outliers, as suspicious kinds of activities, right? So anything that's blue, I don't care about it. Anything that's yellow, that is definitely going to be the focus going forward here, right? So one more chart I want to show you, Control Enter to run this. And at this point, anything that's an actual anomaly, I'm coloring red, or I'm highlighting with a little red border around it. Okay, so everything Vertis is kind of one of these colors you just get from Plotly that looks kind of nice, I think. But I wanted anything that's an actual anomaly charge to have a red circle around it. So you can see that this high expense charge for that hotel, 3,406, is actually not an anomaly, right? These over here are not considered anomalies either. And this one down here that's packed in kind of with the rest of the group with the red circle around it, 514, that actually is an anomaly, right? So it's kind of like tucked away here. It's hard to find. These three over here are being singled out as 3 more anomalies, right? But as you can tell, it's not just the high charges. And so the charge and amount of US dollars is on the y-axis. The timestamp is on the x-axis, right? So it's the time series analysis as well. But you can see it's not really based on like the time of the day necessarily, I think. Oh, there's a couple more in here. So these are kind of hidden, and these are actually lower transactions, right? So this is S33, S31, S57. Actually, wait a minute. Wait, what's going on here? Oh, that's fine. That's fine. I see what it's doing. So it's just attaching a label to that. I think that's fine. Okay. But you can see how the anomalies are kind of sort of hidden in here. Here's one down here. I see S2, S21, or whatever that thing is. So it's not just the big expenses. It's not just the, the extravagant charges on this card. Isolation Force is really looking at this charge relative to the peer group and calling it out as being very different. And we have to figure out why, right? So there's going to be a small audit at this point. Probably, I mean, I'm just doing this as a case study, but if you really work for this corporation and you're tracking these people's expenses, these are the people that you need to focus on. Okay, so set up a short meeting. Probably it would be one-to-one meeting. I don't think this would be a group meeting because some of these expenses are probably not necessarily, you don't need to share that with the rest of the team or the whole corporation, right? But maybe the first time you're doing this, I think one-to-one meeting makes sense. Maybe eventually it'd be more like a coaching session or whatever. You might have a few people in the meeting. I'm not sure how you want to run this, but anyways, like we did find the anomalies, so we're in a good spot right now. So this is exactly what you would expect. Expensive is not necessarily anonymous, right? So this over here was not recorded as an anomaly. This is not over here. Sometimes it's just buried in plain sight, right? And it's right in front of you. I found a couple more down here, right? So that's really the things that we have to focus on. And this is just the first time that we're running this model too. So maybe if you go to those people, right, have a one-to-one meeting, knock it out in a day or whatever, right? Figure out like what's going on. Why are these coming back from the anomaly detection tool that we just set up? And do we need to tweak it? Maybe we have to change some of these hyperparameters. If all of these charges are totally legit and Isolation Force is saying, hey, these are weird relative to the rest of the group, then we have to come back and tune the hyperparameters, right? So this is like kind of trial and error. I'm not saying you're going to get it right on the first try, but it's definitely a good place to have a conversation. And I think we're definitely headed in the right direction here, okay? So everything has to be measured in context relative to everything else. Again, it's not expensive, and that's an anomaly. It's really the context of how these expenses are reported or being charged to the card relative to the rest of the group. That's what you have to look at, right? Is there some kind of pattern, like 7-day rolling average, and a pattern is teased out? Maybe it's a 30-day rolling average, and we find more of a pattern. So that's something to be cognizant of. Does it occur on the typical day of the week, on the weekend, and not on the weekends, things like that, right? If people are trying to bury their charges in the sea of other credit card transactions, right? Like maybe a rolling average could be something that could help you, right? So I'm just testing some different ideas, just playing around with some things here. Feature scaling, that's what we just talked about. You can change the features that you're training the model on, right? So I had an original date and the transactions and the charges and things. I created a bunch of new features and then created standard deviations, means, 7-day rolling average, 30-day rolling average. So you really have to test some different ideas and see what actually works for you. I'm not saying this is absolutely the best way to do this. Sorry. There's no like definitive best way to do this. I'm just testing a few ideas. This is one way that you could do it, but maybe in your exact scenario, maybe it's a little bit different, right? So now I'm looking for anomaly flags. I'm going to pick anything set to 1. So a 0 is a non-anomaly. Anything that's set to 1 is anomaly, and these are the people that we have to follow up with and check these transactions, right? So if we go over here, you'll see anomaly flag set to 1. This is where is it? Okay, so all of these over here are set to 1. Okay, so these are the top 20 charges. And this is the reason why. So 25.9 standard deviations above the 30-day median, which is the average, right? Mean is the average. Median is the middle number, right? This has a huge standard deviation. That's why that one's being called out. And you see just the rationale behind this, right? And then, of course, over here you would have timestamp and the person's ID, right? So we don't have any people's names over here, but we can map this to some kind of mapping tool and figure out who these people are. So at this point, it's anonymous, and that's fine. I think that's what you want for the data scientist or the engineer or just the business analyst that is doing the analysis here. But when you're setting up meetings for these people, to find out why do they have these types of transactions on their credit cards, then you can do a VLOOKUP or whatever you need to do and get back to the actual person's email and person's name. So I think that's it, guys. What are we at? 25 minutes. So that's good. I think I covered everything that I want to cover, got through it all. 25 minutes, so pretty efficient here. So that's it. Let me know if you have some comments. Make some comments in the comment section. I try to make these videos very what's the word? Very realistic and very relevant, relative and relevant too. So you can copy and paste your data and do your own specific analysis, or just run my analysis, right? You can just copy and paste the data in your own Jupyter notebook. I will share all of this code with you, so you have the original source code. You're good to go. It's going to work right out of the box, guaranteed. So again, if you don't know something here, go ahead and Google it, test the code, use ChatGPT if you have questions, right? If you have very specialized, specific questions, put that in the chat. Love to hear from you guys and just see what's going on. So that's it. I'm going to wrap it up. This is the end. I always put "and" at the end just so you know it just doesn't continue and maybe I forgot to do something. This is it. So yeah, there you go, guys. That's isolation forest, define excessive credit card charges, and there we go. Mission accomplished. Thanks for your time today. Really appreciate it. I'm going to wrap it up right now, and I will see you guys in the next video. Bye for now.